Hello boys and girls, this is Professor Nelson from Electronics. If you have one of these, a second-hand microwave diode from some equipment you have repaired, well, today we are going to see what applications you can give it to give it a second chance. First, this is a microwave diode which works in the same way as a conventional diode. That is, it allows current to pass in only one direction. It has its cathode and its anode. Among the characteristics of these diodes is that they can withstand high voltage in reverse. In the case of this model, it supports 1,200 volts in reverse and allows only 350 milliamps of current to pass. A big difference compared to the conventional diodes that we usually use on electronic boards. As is the case with this one, this is a normal diode that allows 3 amps of current to pass at 1,000 volts in reverse. That is, it can withstand 1,000 volts in reverse. However, if you have these diodes, as I said, secondhand, today we will see what practical uses you can give to these diodes, since they are somewhat different from the common ones we use, like this one here. So let's see in what applications we can use them. Very well, as a first application, what we can do is replace a Zener diode. This is a 9-volt, 1-watt Zener diode. And if you want to know more about Zener diodes, I invite you to watch one of the videos on the channel. For now, what we are going to do, this diode will be replaced with the microwave diode. Here you can see the diode as it is connected. The cathode at the bottom, the anode at the top. We have the resistor that limits the current. The current that will go from positive to negative. And the voltage drop in a microwave diode is approximately 9 volts. So it serves to replace the 9-volt Zener diode. So between the ends it needs approximately 9 volts. Normal diodes only need 0.7 volts to work. However, this one here is special, so it requires 9 volts. Let's do the test to verify that voltage drop. And after that we will make our microwave diode feed 9 volts to the circuit we have here, giving rise in this case to the replacement of a Zener diode. Let's measure the input voltage. We measure the voltage. We have 20 volts. Let's measure the diode. Negative to the cathode, positive to the anode. We have 9 volts. So a current is passing from positive to negative. Now if you want to know how much current it is, well, I invite you to watch one of the videos about Zener diodes. For now, in this case, we can know that it is. If we have 11 volts in the 100 ohm resistor, therefore, we have 110 milliamps, which pass from here to here. Now 100 milliamps is enough to feed this circuit. Let's feed it by connecting the negative to negative, the positive to positive, and make our circuit work. Well, it's already connected. Let's connect positive. There we have it. Our circuit is working. We check the voltage. We have 8.6 volts. We have a slight drop, but it is still maintaining the voltage. In this way, you can use this microwave diode to feed a circuit replacing a Zener diode. This one here is going to allow you to handle more current or more power than a Zener diode of this type. That would be one of the applications. Now let's move on to the next application. Guys, as a second application here I have a fan. A 12-volt fan that requires 150 milliamps of current. If we have a power supply of 20 or more volts and if we connect it to our fan, it will burn out. So we need a way to reduce the voltage. To do this, we can use our microwave diode to reduce the voltage drop across the fan. Remember that we saw that the diode has a 9-volt drop. So we are going to take advantage of that property to reduce the voltage coming from the power supply to the fan, and thus prevent our fan from being damaged. Then we will make the connections to be able to connect it to the power supply. You can see that the fan is working. We have the diode connected. We are going to make the voltage measurements. First, the input voltage of the power supply. We have 20 volts. There we have 20 volts. The voltage that reaches the fan. It is only 12 volts. The voltage that is reaching the fan is the voltage that it requires. It means that the diode, this one here, we can use to reduce the voltage and to be able to connect a fan to a higher voltage power supply. It is one of the applications that can be given to our microwave diode. Connections are positive to anode. Negative goes to the fan positive. It is a series connection. The voltage is divided between the two components. And this way you can connect this fan to a higher voltage power supply without it being damaged. Keep in mind that the current handled by the microwave diode has to be greater than the current indicated by the fan. It can handle 350 milliamps, and what it requires is 150 milliamps, so I can use this microwave diode. Comment in the comments section if you have ever seen microwave diodes used in this way. Well guys, that's all. See you in the next video. Don't forget a like, it helps the channel a lot. Bye bye.